Alright, now I'm going to show you how to check an equation using the calculator. And I'm using one of the equations that came from your e-text in Module 3. Let me first turn the calculator on and turn it just to the regular screen. I'm going to hit quit to do that, clear everything out. And this is the equation that we have right here. First, you want to know where the y equals key is, and that's right here above in the upper left hand corner, and you click that. Now sometimes one of these plots is on, and if it was, it would look like that, kind of in dark. And if you're down here and you see something like that up there, it will not work very well. So go up there and hit enter and turn it off, and now you can see it's off. That's just for future reference. Now the only variable you can use when you're using the y equal key is the x variable, and there is a shortcut for x, and it is right next to the alpha key, and it looks like x t theta n, and it's right here, and you click it and you get x. We're not going to use b, we're going to use x. y1 is going to be the left side of the equation always, so we'll put 2.1 parentheses. We write it exactly as it is there, except we use x instead of b. X minus 3.4. And notice that we use a minus because it's between the b and the 3.4. And that is the left side of the equation. When we're solving equations, we will always let y1 be the left side and y2 will be the right side when we're doing our checks. Now when we're doing the right side here, the first number is negative 4.3, and we do use the negative key, which is down by the enter for the negative there, 4.3, and notice it looks a little different than the minus. It's higher and it's shorter looking. Open parentheses, again x instead of b, plus 3.75. Close parentheses. Now we use minus because it's in between the parentheses and the 2.44. 2.44. And you're copying this symbol by symbol exactly identically to the right side of the equation. Now I intentionally am going to check an incorrect answer first and then a correct one to show you the difference between the two. The next thing you need to do, as long as you're checking something on the calculator, is to check table set. If this is your own calculator, you wouldn't check this as often, but usually if you're using the one in the testing center, you would want to check table set. Well, table set is way up high underneath the display screen, right above the word window, and that is the second meaning of the window key. So you would hit second first and then the window, and you get a screen that looks like this if you are using a calculator in the testing center where they've just been reset. And what we want is we want independent to be on ask. Independent refers to your x variable, and we want to be able to input the answer as an x value. And so we go over to where ask is and hit enter, and then it switches it from automatic to ask. There are some times when you would like it to be automatic, but most of the time we want it to be set on ask. And then we go directly to the table feature, and that's above the graph up on the top row of functions underneath the display. Table is right there, so we hit second and then graph, and that gives us a table. Now if some numbers are already in your table, we use the delete key rather than, let me put that down here, because that's a special key, DEL. It's located next to the left arrow here. Rather than quit or clear, If you try clear by accident and it doesn't work, just wiggle it around with the arrows and then hit delete, and it'll work. You have those 3 different keys that allow you to eliminate things, and the delete key is the one you want. Now let's put the wrong answer in, which I made wrong only by having the wrong sign. The actual answer was a decimal that went on and on forever, and I rounded it to 3 decimal places, the thousandths place, and I put an approximately equal symbol rather than an equal because I rounded. Now, I could have rounded to 2 places, and I'm going to show you that as well. But at any rate, I'm going to put the wrong answer in first, and that is 1.785. And when I enter that, I get a left side, y1, which is not at all equal to the right side, y2. The left side is -3 and a fraction. The right side is -26. All right, and so then I do my problem again. If you get a wrong answer like that, that means you did something wrong. The first thing I would check is to make sure I actually entered the left side and the right side correctly, because sometimes you'll hit a wrong key inadvertently, and that in itself would make it wrong. But I did enter everything correctly, and so I go back to my table after I do my problem and find my mistake, and I enter the right answer. And you don't have to re-enter at y1 and y2 because you've already done that. You just re-enter your answer and see if it checks. And this is what a check looks like. When I put that number back into the left side and right side, it should make the 2 sides equal. And it does. The left side is -10 and 89 hundredths, and so is the right side. Now these were approximate answers because I rounded off. Sometimes when you round off, they don't look this equal. Okay, so I'm going to maybe round this number to 2 places instead of 1. When I round it to 2 places, I get -1.79. And I'm going to show you how a good check looks when you're rounding, and your rounded value, which is only approximate, sometimes doesn't yield exactly equal results. So I'm going to check that number instead, -1.79, and I'll hit enter. And you can see that when I put that in, which is rounded to 2 places instead of 3, it comes out to very close values. Like if I had rounded the second value -10.87, it would have rounded to -10.9. So the 2 values, the left and right, are very close, but not perfect. And you generally expect that to happen when rounding is involved in the answer. If rounding is not involved, you expect to always get exact answers.